Hello everyone. Hello everyone. Welcome to Inter IT Technique 10.0. This is a live testing session of DRDO's mid prep event. We have with us the judging panel, Mr. Sudhir Dhamija, Mr. Akshay Jain, Mr. Hed Shah, and Mr. Gaurav Gardi, and also Mr. Kirpal Singh. So we are gonna start soon. Uh, so for the first team would be Team 17. They would be joining. Team 17, please raise your hands. Team 17, two of you only will be presenting or someone else? Okay, there is. Okay, Team 17. Now you can present on a system and start the simulation. Hello, Team 17.
Yes, we are doing it. Just a minute. Hello, everyone. So actually, the problem is the world has been launched, but we were not able to control the vehicle. We tried to develop different, like we tried to implement some things, but at the end we were not able to do it without errors. So we submitted the code without the control thing, and I think today also it's not working.
Uh, Bhavya, you can just try running it. Okay, Team 17, are you trying to debug the issue or are you trying to run the code? Hello?
Yeah, actually, we were trying to run one part of the code, but it's somehow not working. Like,
Alright.
even
So
though we were not able to complete the PS anyways, but it was moving in, but
that's
right
okay.
now it's
Do
not.
you want to, just think out loud so that it's not too silent? And I don't know if I feel like you're stressed, so maybe it helps if you think out loud, like what you're trying to do, and also so that we are not clueless.
Yeah, like we are trying to run the one of the test files that we made, uh, but now the SITL is taking a lot of time to start up.
All right, so it's the initialization that is taking time for the pod
Yes,
software, right?
yes. uh, we'll try running a code which controls the Prius car, so that we manually coded. But if that doesn't work, uh, like I think we'll if it works, we'll continue. Else, we may need to stop.
No problem. So you're trying to manually control to check whether the simulation is running. Is that right?
Yes, we are trying to do that.
Okay.
Are you giving some commands from the keyboard to run the car?
Uh, no, actually, a set of test commands are already hard coded in the Python script, so it should run just by running the script.
Can you check the topic whether these are being published?
Yeah.
I just noticed. So, are you using some kind of emulator in Windows to or virtual machine?
Actually, we are using a Windows subsystem for Linux for this particular PC. So,
Oh, I see. I see. Okay.
mm, the previous topic is being published, but
No, no.
we'll
You
try
just
it
check
again.
the topic is published. Can you echo the topic and check if the messages are being published into the topic? The cross topic echo to yes.
Yeah, I think the node has not been set up. I'll try it again.
Oh, I see. So there is something else. Yeah.
Team 17. Now we'll go with the next team. But if you are able to run it after this session, this run, then please let us know ASAP. Okay.
Yeah, sure.
Okay.
Okay, so can I present my screen?
Yes, you can present.
Okay, so good morning, everyone.
Morning, everyone. So actually, we have used the drone kit package to move the drone.
Yeah, so we have used the room kit package to move the room. So I'm waiting for the GPS to show here so that I can arm and take off the drone.
Just to make sure you're recording the back files, right?
Yeah, I'm starting the recording of the backside.
Cool.
Just to confirm, these are the topics I have to record, right?
You also have to record Mavros local position, pose, and Mavros state.
Okay, thank you. Yeah, so I'm now running the script for moving the drone. Actually, I don't have that much graphic card, so since that's why the world is blurred, I guess. So we are basically drawing the contours based on the segmentation of the road, and the drone is basically following this red line.
So basically, in getting this red line, we have used the depth camera images to get the distance vertically, and using that difference in the distances, you have segmented the road and the other terrain into classes and made the red line.
Okay, so I'll explain to you what the procedure was. Actually, we used a naive approach that since we are starting from a road, uh, we fi we finally took the depth image and converted it into a pseudo grayscale image, and finally applied k-means segmentation on it with two classes. So that gave us the pseudo grace that segmented the pseudo grayscale image into two classes. One was road and another was not road. So we used an approximation that since we are starting from the road, the majority class that will be visible in the segmented image will be road. And moving on with that assumption, what we did was we considered that our drone is as it is visible to us in the depth depth image. We assume that the drone is moving along the y-axis. So we took the mean or the midpoint of all the road class along the y-axis, and our drone started moving along the same. We just drew an imaginary line along that path, along that major axis, uh, along along the midpoint line of that road class, and finally we've made the drone follow the invented red line in the same. So that was our approach.
And yeah, so like we didn't get that much time to fine tune this and make it more generalized. Like we are facing some error right now. Like yeah, so this is our approach for moving the drone, and it has successfully ran in the world one completely. I know
Right.
maybe.
So your approach probably won't work if there's a turn or if there's an angle, right? Because you're not always moving along y-axis.
No,
No, sir.
it will actually work along the y along it will the this approach will work along all the turns and twists as well. The thing is, we have assumed that it is the drone is moving along the y-axis according to the visuals we are getting. So as the drone moves and takes turns, the y-axis that we are talking about is relative to the drone, not to the world.
Okay, I see in the image frame. Okay.
Yeah,
Okay.
in the image.
So what we did for moving UGV was we recorded the back file for the CMD well topic, and we will run the move press script, which will convert the dist message to control message.
So you are mapping the road using drone, or you have already segmented the route beforehand, and then your drone is following that route.
Um, we are actually what we are doing is we are taking the depth image. So what depth image does is since the road is in this particular world, the road is at an optimum distance from the depth camera, and the side of the valley and the side of the mountain have a variable distances. So what depth cam does is it returns to us an image with a road most probably colored in one gradient, and the mountain and the valley side colored in other gradients. We finally convert that depth image into a pseudo grayscale image, and we apply k-means segmentation on that. So what that does is it to keep the things computationally less expensive, we chose only to have two class of road and not road. So what k-means segmentation does is
That's
it.
fine. What I want to know, that depth image you are taking. So you are assuming that your drone will have a camera, depth camera, and will take the image on the fly, and you will process it.
Yeah,
and you will
that is what
pass
we will
on
do.
the coordinates to the UGV to navigate.
Not exactly all the coordinates. We are just creating a midpoint line, and the drone follows the centroid of it.
That's okay. The drone is used to navigate your UGV.
Yeah, drone is used to navigate our UGV.
Yes. So that is the process I want to understand. So your drone will have that camera.
Yeah, drone will
It
have
will,
the camera.
okay. And then you will trace the route and you pass the coordinate to UGV.
We actually don't trace the route. We record the movements of the drone itself, and we finally
Mhm.
convert the movements of the drone itself into the movements of the car.
Okay.
So for this approach to work, the initial alignment of the drone and the car should be like almost similar, if at all facing in the same direction.
So now you're not using your drone to get real-time feedback of the car's position, right?
No, sir, absolutely no.
Okay. Yeah, that's why we
So
see it uh, go out. Okay.
yeah, so like we were not that efficient. Like we didn't get the time to make that conversion between the dismisses to control messages efficient.
It's okay. So that's it, right? Your car,
Yeah,
did it stop or did it fall off? Or can it go on?
like it got it got off the wall. Actually, it
Yeah,
got off the road.
right.
Yes, sir, so this was our approach, and yeah, I think we have done the best that we can.
All right. So you have recorded the back file for the whole, for the mapping and the navigation separately,
Yes, sir.
right?
Yes.
All right.
For the navigation, I didn't do. Can I do right now?
Oh, okay. You
Like
should have.
for moving the priors, I didn't do. I can do.
Yeah. Sure.
So in the meantime, I'll tell you what we thought of doing if we had a little bit more time. So one of the major things that was of very much that was a big challenge to us was that movements of drone was fundamentally different from the movements of the car. So we had to approximate the since we were using PID control, we had to approximate the errors in different types of errors that occurred in the motion of the drone to what type of motion we would require for the car. So if uh, given that we had more time, we would have optimized it a bit more. And one of the other things that we thought of doing was taking making the car travel manually through the entire route and making the drone move autonomously throughout the entire route, and finally train a machine learning regression model uh, just create a model that finally optimizes the motions of the drone, which will be then relayed as motions of the car. So that is what we thought of doing. But given the lack of time, we weren't really able to accomplish that.
I'd just like to comment on this approach. I think using machine learning to learn the transformation between drone and car is not general enough because it will depend on the type of the road. As you said, the dynamics are fundamentally different, right? Your car has a turn radius, whereas your drone quadcopter has zero turn radius. It can rotate because of the yaw, and that makes a very big difference.
Yes, for that particular thing, we approximated the zero turn movement with turn movement of the car. We have actually done it. The drone moves exactly in the same way as a car would. So there are no motions of the drone that are happening in this test run that won't really happen in a car.
Okay. But why aren't you using a drone to provide feedback to the car? I guess that's the biggest place probably where you needed to work. My is my thinking, but of course.
Yes, sir. So, like, we initially thought of the providing instructions of how to move, but we later decided to just record the prospect file because of the lack of time and maybe lack of guidance or so. Like,
So, like
like
we
we
had an idea of passing the coordinates, like storing the coordinates in some way from the drone and passing those coordinates to the car, and then we could have easily moved the car. But like it wasn't, we couldn't do that in the given amount of time. So we just recorded the raw data from the back file and played it from the car.
Cool. So if you're done with the ROS file, have
yes,
you
sir.
recorded the back file?
Can I get the confirmation that this is the topic that I have to record?
Yeah. No, you need there are just record a single file with all the topics, right? There are 5 topics.
Yes,
There
sir. I
is
have recorded
clock.
for the drone moment, but I'm asking for the
Yeah, you
car.
need to record
Uh,
clock as well.
the topics which were asked before for World 1 and World 2, those only like you have to record those again.
Okay.
Yeah, but you need to record all 5 of them, even for this run.
Okay, so give me a minute.
So you need to record Mavros slash local position pose and Mavros slash state and gazebo model states. All right.
Thank you.
And once you record the files, can you display the MD5 sum of both the files so we can write it down and then you can upload the files?
Yes, sir. Sure.
So one one of the other flaws in our this working mechanism, not really flaw, but the limitations of our working system was that we did not have a GPU to run this entire thing on. So there was this delay of 3 to 5 seconds that we were having when by the time that the signals that the drone recorded when it had to turn and when it actually turned. So that also caused a lot of issues. We weren't really able to solve it since we have run the entire setup on a CPU only. So that was another thing we weren't really able to cross.
Yes, sir. Like hence we see that the drone stops sometimes in while taking a turn because like the time it takes to reach the simulation is different from the time it actually moves.
Yes, sir. So the sizes are 5.5 MB and 112.5 MB.
Can you display the MD5 sum?
Sorry, sir.
MD5 sum.
MD5, sir. I'm not really like aware of it.
Okay, let me give you the command. Mm. You can prepare to upload. Do you know where to upload the files?
Yes, sir.
You just have to type MD5 SUM and the file name, I think.
MD5 SCM.
Mhm.
So should I copy paste this in the chart or something?
Yeah, that would be nice.
Yeah, then.
Thank you.
Oh, this was for the final bag and for the previous part.
Both the files. Can you do it for both the files?
Yes, yes. Yes, sir. The first one for final and second one for later part.
Okay.
Oh,
Okay, now team 10 will join. Uh, team 10, if you are present, please raise your hands. Team 10, please raise your hands. So Team 10, you can start presenting. Hello. Team 10, you can start presenting.
Hello.
Hello, Rohan.
Hi. Hi.
Okay.
Am I audible now?
Yeah, yes, you are
Okay. So I
audible.
just I just share the whole screen, right?
Yeah.
Okay. Cool. Just one second. Share screen. Okay. Yeah. Cool. So is it all visible?
Yes, it's visible.
Okay. So I'll just start with the first part of our solution, which is mapping the road. So this is the Word file. I'll just launch QGC alongside with it. Just to confirm, this is how the world should look, right?
Yes.
Okay. It'll take just a minute to get the GPS log, and then we can start our notes. Yeah. Okay. So we don't need this now. I'll just delete the car and the box models that are not required for the mapping part. Here's the drone. So this was mentioned in
Just
the
to make
document.
sure
Oh
you're
yeah, sir.
recording back files, right?
Okay. No, I will record alongside. Like once I run the notes.
All right.
These are the topics, right? That you want, or anything
There
else?
are 5 topics, right? Yep.
Yeah, those same that were mentioned earlier, right?
Yes, it's correct.
Okay, cool. So I'll just start the backfiles once the mapping starts. Okay.
Cool.
Okay. So I'll just minimize this. This is not needed. Just one sec. These are the raw spec files. Okay. Is it all visible?
Yes, it's visible.
Okay, so the mapping part has begun. We'll just see till like how much road can the drone actually map with the turns as well. Uh, do I need to explain anything right now, or will that take part in the presentation tomorrow?
It's up to you. If you like to explain, you can explain.
Okay, so I'll just give brief inputs here and there that algorithm is depth based for detecting the road. And hmm. Okay, so this black line basically kind of tries to predict where the road is heading. And I think okay, so I think it has detected the wrong plane. I'll just stop this. I'll should I close the ROS bag as well, because it has to be different ROS bags, right?
Yes,
For
correct.
okay.
For navigation and mapping, you have different aspects.
So I'll just close this right now. Okay. One of my ROS bag should be here. Cool. Okay. So the file, like from the mapping, a CSV file is generated, which is stored inside a maps directory. And now I'll just use that to traverse the Prius, like as long as the mapping took place. So for that we have final. Okay, I'll just wait again for the GPS lock and the ROS bag as well. Okay, so I'll set the initial height to around 18, like we were told to keep it under 20. So let's just keep it at 18. I'm just checking if the drone is armed. Yep. I'll delete this box because what we submitted, that will work if the drone is spawned on the car as well. So yeah, good. Just one sec.
Again, to make sure you're recording the back file, right?
Okay. I'll set this to 3, like the CSV file after mapping is saved like world 3 dot. Okay, so there's our segmentation. I'll minimize this. This is not needed. 3. And I'll start the map. Is the car visible on your screen? Like, is it moving or?
Yes, it's moving.
Okay, cool. So it will just run as long as the road was mapped, which wasn't fully in the first iteration.
So what is the black image on the top left?
Okay. So that's the basically the center detection we're doing for the car, because we need to extract the pose, velocity, and orientation right from the visual feedback, as
Right.
we don't have any sensors on the car. So basically, drone is providing all that to help move the car. That's it.
Okay.
I'll just leave it until it runs. You were saying something? Sorry.
Your drone is flying overhead right now, real time with the car,
Yeah,
right?
Can you see? Here's the
Okay,
drone
perfect.
and here's the car. Okay,
Right.
so I think now it's just gone off road because a couple of waypoints were mapped incorrectly.
Yeah, you can keep going as long as you think it can come back. Otherwise, you can.
Okay, and
Stop.
can I try to map again? Is that allowed, or only once it's?
I'm not sure. Just give me a
Okay,
moment.
okay. Like if not, it's fine. But yeah, because of the in the new world, the depth of the road isn't that clearly segmented, I guess. And our algorithm is majorly on depth-based plane segmentation. So I think that's why it got off track so early in the stage.
I think we can give another chance.
Okay, cool. I'm not sure if it would be any better, but okay, I'll try to just reset everything. I'll close this background, okay? I need to manually delete that CSV file that is generated from the mapping. So I'll just do that right now. Maps. So yeah, if I'll just show it also. So these were the CSV file that was generated right now. So I'll just delete this.
What all data it's containing, that CSV file?
Okay, so it's containing.
Hello, am I audible?
Yes.
Yeah. So when we run the segmentation node where we map it, we store the XYZ of the road. We basically try to get a mean path for the road, and the XYZ is stored in the CSV file, and then we iteratively try to reach
Is it
the
GPS
waypoint.
coordinates or some local coordinate system we have created?
The local coordinates, where the drone starts, that's a local coordinate system for it, and the points are mapped with with respect to that coordinate system.
Basically the case, we're given R2 pilot to work with, right? So in that, what happens is wherever the drone is spawned, that is considered as home position, and a map frame is created there. So it's easier if you work with that.
Okay.
Cool. I'll just relaunch everything. Okay.
Just one question. So, how are you transforming from your image frame to your ground frame? Let's say the local coordinate. How do you get the rotation or the transformation matrix?
Okay, so we make use of the images and the point clouds. So in the camera frame, we get a point from the point cloud. So that is XYZ. Now Then there is a transformation from the camera frame to the quadrotor's local frame. That is one transformation matrix. And then there is a we get the odometry for the quadrotor, and we create a rotation matrix from that, and that is applied to the coordinates that we have in the drone frame. So that completes the entire transformation.
So you essentially calculate the rotation matrix with respect to the initial plane, right?
Yeah.
Okay. Okay.
Okay, I'll just relaunch everything. Yep, just waiting for the GPS lock again. Okay, GPS lock is there. I'll just check if the drone is armed. Yep. I'll just delete the car and the box models once again. Those are not required. Okay. Just one sec. So segmentation default not launch. Yeah, so this gives the code on Pera. This is mentioned in the doc as well. One second. Minimize the extra screens. And I'll just run the bag again. Here, the arrow basically suggests the approximate vector where the road must lead to. So okay, I'll just see if it works this time.
You're recording a different back file, right?
Yep. It's recording a different bag every time. So after the presentation, should I send all the 4 bags or?
You can just pick your best, whatever you think is your best.
Okay. I guess I'll just see in this iteration if it's better then. The drone is visible, right? It's not too zoomed out.
Yeah, it's visible. So how do you decide for the drone? Like how is your controller working? The planner working?
The mapping planner, basically the segmentation part.
No, the planning, like where the drone should go next with the quadrotor.
Okay, I'll let my teammate explain that. Just one second. I'll mute myself.
Am I audible?
Yes, you are.
Okay, so could you just go over what exactly do you want to know?
I just want to know how does the drone know which direction to go? So the planner for the quadcopter.
So there are 2 parts to this. First is the segmentation part. where we use jetway segmentation in order to segment out which pixels exactly belong to the road. So once we have that, we follow three cascading algorithms in order to calculate which is the possible direction. So if the pixels of the road dominate the image that we are getting, this means most probably the road is extremely dominant in the image, and the drone should probably go in the direction that it's currently going in. And that's what you exactly see in when you see that black arrow coming up. The second case is when we are getting a good fit for a rectangle to the road. So we compute the minimum area rectangle which successfully bounds the road, and the axis of that rectangle is the direction the drone should go along. If the rectangle is a good fit, we use this rectangle. Otherwise, move on to the third part, that is principal component analysis. If this means that the road is not the greatest shape for a rectangular fit, so we use principal component analysis in order to calculate two of the directions, and the axis is again chosen as the direction. And in addition to this, there is a simpler corrective measure as well. So if the center of the road that we've detected strays too far from the image center, this means that the drone is maybe going too far from the road. So in that case, instead of going straight ahead along the axis, we go perpendicular to the axis to bring the road back to the center, to bring the drone back to the road center. And this waypoint is a corrective measure and is not included in the waypoints for the Prius.
All right. Thanks.
Okay, so it roughly mapped the same amount of road, I'm afraid, but I'll just run the Prius again and yeah. Okay, okay, so the drone is armed. I'll remove the box that interferes with the Prius detection. I think initially the drone is spawned too backwards from the Prius. Like we wanted it to be on top of the car. So that's why it's not immediately detecting the car, I think. Yeah, just one sec. I'm not sure the car would move because I think the drone was on before and that's why it's not detecting the car. Yeah, but the drone is spawned to before the car. Our code basically runs well if it's spawned on top of the car like in the original files. So basically it, like just spawns on the top of the car, it launches arms and then the detection part starts. Yeah, I don't think it would move because the drone is behind. Should I just close it?
Yeah, I guess.
Yeah, I mean, like the direction part did start in the first iteration, right?
Mhm.
So yeah, so basically, like in the video files also we submitted, we just spawn it on top of the car. Okay, I'll just close it. I don't think it will
Yeah.
detect this way. It's too behind.
Yeah, I think that's fine. So your last one was good, so you can just keep the back files
Uh,
for that.
yeah, cool. I'll just keep the back files. Yeah. I'll
Can
send also. Yes. Yeah. Yeah. Sorry.
you display the MD5 sum of the back files you're going to submit?
What? Sorry. MD.
MD5
Okay.
sum
I'm not
SUM.
sure what that means.
You just have to type MD5 SUM and the file name.
Okay. Yes. I'll just check which one is the
Mm-hmm.
recent one.
Sure. Just
Here are the
make
back
sure you only
files.
do it for the two back files corresponding to the successful run, the run which
Okay,
moved.
so it's 1038 right now. So probably that. Okay, so the 1019 and 1025 files were the correct when the detection
Mm-hmm.
worked. Okay, so I'll just run those two.
Yeah.
So this is 2610 17. Okay, here is one.
Can you copy paste both the
Yeah,
sum?
just one second. Next is 23, 22.
And can you copy paste it along? So copy the whole thing so the file name is also there.
Should I send the whole thing?
Yeah, that would be nice.
Okay. Just on the AMeet chat.
Sure, yeah, I can put it on the chat.
Yep. Did you get it? Okay, it has my
Yeah,
system info as well. That's fine.
thank you.
Okay, so should I just close everything?
Yes, I think you're done. Thank you.
Okay. So can we leave, or is there something else?
I think we can move on to the next team.
Okay, we'll leave. Thank you.
Team 2 will be joining. Team 2, if you're here, please raise your hands.
Uh, Hello, am I audible?
Yes, you're audible. Are you only from your team?
Yeah, I guess
Are you?
some other member will be joining, but mostly I'm alone.
Okay, so like you can start alone.
Yeah, sure.
Okay, sure.
I'll present my screen. I hope my screen is visible.
Yes, it's visible.
Yeah.
Stabilized flight mode.
Yeah. So solution goes like this. First of all, we are focused on mapping. So actually a file structure. So in a file structure, we will be first of all mapping, running a script to map the whole road, and then after that we'll be saving the path that is captured by the drone, and then that path will be used by our car to track it. So let me delete the praise model because it's not needed while mapping. Yeah, so let me show you the file structure. So it's like this is our main package, and this is the these are the packages given by you guys, and this is the solution package which has scripts, like all the required script, all the scripts that we require. Now, yeah, so I'll be running this summer mapping script. Just a second. Yeah, so here I'm waiting for the GPS signal. So I ran my script and it showed waiting for global position. So this means GPS lock has not hit.
बोल कि
I guess there is some issue. I'll just relaunch everything.
Communication lock. Stabilized light mode.
Uh, okay, just a second. I guess there is some issue.
Armed. Disarmed.
I'm really sorry. I guess it's a new world, so it's taking a bit more time to initialize it. So just give me 2 3 minutes and I'll sort it.
No problem.
Yeah, hello. So actually, we have the code for like automatic takeoff also, but apparently it's not happening. So, anyways, I launched it from QGC, and let's just hope. Uh,
Just to make sure you're recording the back files, right?
yeah, yeah, I'll be starting it.
Cool.
The Mavros is it's still not publishing the data. I'll try relaunching it. इसमें कुछ करना होता है क्या? कुछ व्हाइट वाला लॉन्च करके देखो. Just for this. वर्ड में दिक्कत है क्या यार इंस्टॉलेशन? इसमें कोई दिक्कत नहीं है। लॉन्च फाइल में कुछ दिक्कत है। ठीक है, ये खोलता हूँ मैं और अपनी वर्ड में
लॉन्च कर
क्या लॉन्च कर
मतलब ब्राउज़र पे
लोकल ग्लोबल तो वो भी नहीं कर रहा। वर्ड लॉन्च
ये बाकी टीम से बात कर रहे हैं।
अच्छी URL तो गलत नहीं कर अपना वाला कॉपी कर दो।
ये अपना वाला है क्या?
ये अपना वाला वर्ड में
हटा लिया। सही हो गया, डाल डाल डाल।
yeah, hello. Yeah, I'll be trying it now. Uh,
All right.
yeah. So the issue is resolved. So apparently the launch file that was given to us, so the URL to connect to the Mavros was given wrong. So we edited it with the URL that we usually use, and now everything is working. I'm really sorry for this delay, but I didn't figure out that the UDP was wrong, that the file was given to us. Okay, yeah, let's start now. Um, Armed. Guided flight mode. Yeah. So it's working. Yeah, I'll delete the previous mode. Yes, so it's working and it's the drone is moving forward as you can see in the world. So now I'll just explain in brief how are we doing this. Uh,
Sorry, just a second. Can you display your map? Is it possible
yeah.
to display? Yeah.
So this is what is happening here. So first of all, we are taking the like the actually RGB image. Then we are using the depth. So for mapping purpose, we are only using depth data here. So this is the depth data that we are getting. So I hide like this is the elevation. This is the lower part. And then what we are doing, we are dividing this whole image into grids. And then in those individual grids, we fit some planes there. So we do plane fitting, and after plane fitting, we find some error bound that like if the error in that particular grid, if the depth error in that particular grid is below this range, then consider it as road. So by doing that, we get this type of something. So yeah, if you can see, this has very high error ranges. This also has very high error ranges, but this particular road has like some constant or some even error ranges. Then from that we extract the road that we want. So in this way, if you can see, as the drone moves, sorry, as the drone moves, it is extracting the the depth data, and from depth data it is extracting the road.
So what decides the how do you what is the how is the planner working for the quadcopter?
Sorry.
So once you have detected the road, how do you decide the waypoints for the quadcopter?
Yeah. So what we are doing, we are just taking this minimum. Yeah, we are taking the center of the road. So if you can see, I was printing this thing. So these are the starting point of the both the edges found. So yeah, in
All
this
right.
we in this we are getting this particular thing. So these are the edges. Now we apply some norm simple kernel to get these edges, and then like from this 1/4 starting point, we are taking the average center, and then we are moving along. This
Okay.
is what we are doing.
All
Yeah.
right.
So my mapping stopped here in this turn. So okay, we will just continue from there.
So it stops because it doesn't know where to go.
Yeah, it stopped because it doesn't know where to go.
All right. So now make sure to record a separate file for navigation when you start the navigation.
Oh. Yeah, sorry, I just forgot to record the ROS back. I'll just rerun it again.
Okay.
Circle flight mode. Return to launch flight mode. Yeah, so then, explain it more. Actually, the set points are then stored as a numpy array, and then we'll be using that numpy array. So first of all, we are running this pre-processing code, which kind of refines those arrays. So it's like if multiple points are stored within some, let's say, 0.5 meter gap, then it will just like cut them all and treat them as one point, and then accordingly, and actually refines the whole path that we are generating. I'll be launching this again.
Yeah, and this time please record the back file
Yeah.
with the 5 topics.
Sorry. These are the 5 topics, right? Yeah, the
Yes.
recording has started.
Disarmed. Stabilized flight mode. Armed. Guided flight mode.
Yeah, it is recording us now.
Cool.
And this is the drone speed. So as soon as it notices that it's moving out of the lane, so if you see in this case only one edge is being detected. So then we give a set point, which is like, so we have the, it's in our algorithm, we detect if we are if we are on the right side of the road or left side of the road. So what we do is we get this road area, so we calculate the average x. So if average x is, I mean this average distance is on the right side, then yeah, the road is on right side, so we move along that side of it. So
Sorry. So these movements in the along the like the rotation along z-axis, is this the rotation of the quadcopter itself or the gimbal?
yeah, so no, so what we do is if we see the like the depth data, then the edges are like curvy. Let me show you. So like these are the like zigzag edges, right? So it's like
Mm-hmm.
abruptly the depth is the plane is like this, and then edges like this. So what we do, we follow the edge of the road. So our method actually works like this. Uh, yeah. Uh, so if you see, these are the edges. So we at the front part we calculate the like the gradient of this whole edge. So we are getting a gradient one like this and other like this, and then we are taking the average of it. So then we get the target here actually. So
Right.
this is the current drone frame. We are getting the this part, front parts, and we are giving the average value of this all these points as the next target position, and then average yaw as
So
the
this
next
is
target.
the rotation is the actually the yaw of the quadcopter, right? Then
Yeah, right. So
okay.
right. So I'll stop the Rosberg recording because my drone has stopped there. And yeah, I'll be running the winter mapping now.
Yes, and record a separate back file for that, please.
Yes. Yeah. So in this, I have this back file. I'll just rename it just to ensure that nothing is wrong. And if you can see, my mapping file is generated. It's road2.mpy file. So now I will run the pre-processing on it to convert, like to smoothen out this path. So I ran the file and just
I'm sorry, what are you trying to do now?
yeah. So actually, I'm generating the this file. Uh, this road to road npy into the smooth like it smooths out the part, but okay, let's just
Okay,
proceed.
okay. No, it's okay. Take your time. Get it done.
This path is then used by the UGV.
Sorry.
Is this path then used by the ground vehicle?
Yes, the same path is used by the ground. No, just this. ठीक है, we will just use this road to road path. Let me relaunch this to, yeah, I'll be using the white word. And yeah, just a second. Yeah, this world is launched. And Yeah, so if my screen is visible, then this is
Yeah, we can see.
yeah. I'll be launching my script now. Okay, so just to visualize it, I'll be turning on the collision. Okay.
Make sure to record another backfile for
Yes,
this.
yes, I'll be doing. Yeah. So the file is now running.
Hmm.
I'll let it take off. So if you can see, the car is now visible in this RKT plot. And yeah, okay. Let me just generate the RKT plot. Yeah, so this is the approach that we are using. So we have first creating a broadcaster that is converting, like that is transfer forming this TF tree. So tilt link is our camera link, this is our base link, and this is map. And we are, so this is the static transform as camera is fixed with respect to our drone, which is base link. And then base link is now like this is the dynamic transform, which is for that we are using this Mavros topic to check the drone's position. So if you see, but yeah, the our simulation it didn't work. So the car went off the track. Uh, should I just try and relaunch it once again, or
Uh,
Yeah.
yeah.
I think it's okay. Sudhir sir and Akshay, do you think it's okay if they can start again? Uh, you just
Yeah,
want to do the navigation again, right?
yeah.
Yeah, no issues. Go ahead.
Okay.
While relaunching, you can also give us a thought. What changes are you expecting while relaunching the code? Image is same, your code is same. So what parameters will affect after relaunching?
Okay. Sir, actually, the fidelity of Gazebo is quite low. So, even if you relaunch the simulation multiple times, you might get different results. And I think that is what is happening here because sometimes it just gets erroneous data based on Gazebo because the data is not very, um, it's not simulating actual life. So, even in the world, if you see, the road is quite ambiguous from the environment. Only the color is a bit different. The whole environment is sort of a plane of sorts. It's very even as compared to the other worlds where there was a
Yeah,
stark difference between the depth data of the road and the other areas like the mountainous areas and the valleys. So I think that is what is sort of causing the issue here and causing our car to veer off.
and the similar thing actually happened while testing also. Like in World 1, World 2, World 3, sometimes our approach works, sometimes it didn't.
Okay. Maybe you can try to quantify it a bit more. If it's a tool problem or your algorithm issue.
Yeah, so sir, actually, our approach, like our mapping approach, was based on depth data only, right? And it did not use RGB images because the RGB, like the color of the road and the environment, was also very ambiguous in some of the worlds. So we decided to use an RGB only approach because in the three worlds that was provided, the depth of the road was starkly different from the depth of the other surrounding areas. But in this world, as you see, the environment and the road are almost similar in terms of the depth data. So that is what is sort of causing the issue.
Um, but I just note, like last run, we noticed that your quadcopter was probably following the correct path, but the car drifted off.
Yeah.
So, do you think it's just because you don't have proper feedback to the car?
That might seem to be the case, sir, because um, like in the other worlds that we tested, it was giving feedback really nicely if the if the drone did track the path correctly, the feedback given was quite well. And here I think that is an issue.
All right. So, can you just relaunch and also, after the navigation starts, record a back file?
Yes, so I'll be launching it now. Yeah, I'll be recording the ROS bar. Same. Yeah, so actually the performance is, I mean, same only. We just have to retest it again. So I guess, I mean, I don't think I'll be able to improve it now. But I can figure out the issue. So the issue is uh, like while we launch it, the car is not in the exact frame of the drone, and the feedback is given by this only. So what we do is we try like get the position of the car with respect to drone's camera, and then we transform it to a static frame on the ground. But as the car moves out of the frame, then the controllers that we have written for the car, they don't get the velocity and position feedback anymore. So then it behaves like the Stanley control. It assumes that if velocity is not like velocity is zero or something, so it turns its steering to like full -1. That's why.
Okay, not a problem, Atharva.
Yeah.
So tomorrow, during the presentation, it is for all the teams. We can also discuss like what led to the failure or success of your algorithm today.
Yeah. Right.
Okay, so that basic understanding, so that we can have that basic understanding.
Right. Right.
So you can go through this particular word today, and we
Sure.
can discuss tomorrow. Yeah.
Sure. Sure. Sure.
But all of you have done a good work.
Hello, am I
That
audible?
yeah, Muskan.
Hello.
Yeah, Muskan,
Yeah,
you're
Muskan.
Okay. So, like, your voice was not coming. So,
no, you're audible.
okay.
ठीक है. I guess that's it from our side. I'll be ending. Thank you.
Okay,
Thank you
Atharva.
so
All
much.
the best.
Okay, you can still share your back files just to just to keep it. So you can share the back files you recorded,
Yeah. Yeah. Sure.
and also can you display the MD5 sum of your back file?
Yeah. Sure. 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 Uh,
So you just type MD5 SUM and the name of the file.
so will this information suffice? Like size is 11.5 MB, and this is the 571 messages record.
You can just type MD5 SUM,
MB.
MD,
Uh-huh.
D for Delhi,
Oh,
MD5
5.
5 SUM,
Assume.
and the name of your file. Yeah, can you just copy paste this in the chat? This
Oh,
and the other back file also for the navigation.
sure. 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 Sure.
Thank you.
Okay, sir. Thank you. Thank you so much.
Now, team 11 will be presenting. Team 11, if you're here, please raise your hands.
Muskan, what was the team number for previous team?
2.
Team 2. Okay.
Team 11, raise your hands. There is some technical issue from their side, so it will take at least 2-3 minutes for them to join. Team 11, please raise your hand so that I can make you speaker and then you will be able to speak. Team 11, raise your hands, please.
ਇਹ ਟੀ-ਸ਼ਰਟਸ ਵਧੀਆ ਨਹੀਂ ਹੈਗੀ ਫਲੋਟੇ ਵਾਲੀ ਨਾ ਪਰ ਇੱਕ ਬਹੁਤ ਲੂਜ਼ ਜਿਹੜੀ ਅੱਜ ਪਾਈ ਸੀਗੀ ਸਵੇਰੇ ਫੁੱਲਿਆ ਦੀ ਸੀਗੀ ਬਹੁਤ ਉਹ ਹੈ
Team 11, please check you have granted mic and camera access to AirMeet. Divyam, I have invited you to stage. Will you please accept the request?
Hello, am I audible now?
Yes, Divyam, you're audible. Can you ask our other team members to raise their hands?
Other team members also raise their hands.
No, I cannot see their hands raised.
Yes, I have asked. They are just raising their hands. And like since you're facing some trouble with audio, like we will be presenting from one screen and speaking from one device. So will that be okay?
Yeah, that will be fine.
Okay.
Divyam, when can you start? Or like, can you ask our other teammates to raise their hands?
Yeah, actually, there are the other teammates have not joined. So I'll be presenting. Yeah, we are ready to present. So
Okay,
whenever.
okay, you can start.
Okay. So shall I share my screen?
Oh, yes.
Okay. Just a second. Desktop site. Is my screen visible?
Yes, your screen is visible.
Is the terminal visible? I have opened the terminal.
No, your any screen is visible only.
Okay, just a second. Yeah. Is the terminal visible now?
Yes, it is visible.
Okay. Uh, so shall I launch the file or?
Yeah, you can start.
Okay. So I am launching the DRDO world final dot launch.
तो एक भवेश संघारी की स्क्रीन का है.
And in this terminal I am running the Ardu pilot for the GPS.
हाँ, अभी नहीं भेजना था, बोल नहीं पता.
We are waiting for the GPS right now, and once the GPS gets calibrated, we can get takeoff. Yeah. So the GPS has come. Now I'm giving the takeoff. And I am running the RQT for viewing the depth images. So now actually for running our code, since we are using the contour detection, so as you can see in the RQT, the launch pad is also coming as a contour. So actually that is giving a little bit of hindrance. So is it possible for us to delete the launch pad and then run the code? Can we do that?
You can delete the launchpad.
Okay, thank you. Yeah, so now I'm running our code. Yeah, so here basically what the algorithm is that we are using the CV2 thresholding to find out the road and detect the car, and then using the car contour we are getting the car forward vector, and using the road mask we are getting the road forward vector. And what we are trying to do is we are trying to align the road car forward vector along the road so that the car goes along the road, and then using the car center.
Just a second. So, is this you are doing mapping and navigation at the same time?
Yeah, we haven't done the mapping part. This is directly the navigation part. We are
Okay,
doing it
but
independently of mapping.
okay, but then I guess you have to run on the white overlay. You can do it, and but finally you have to run it on the white overlay, right?
Okay, so shall I run it directly on the white world now itself?
If you're comfortable, yes. And can you also record the back file?
Yeah, that is okay. Okay, so then I'll start with the white world directly.
Okay. I just have a question. So you are using image, RGB image for detection and navigation, right?
For the detection, we are using the depth images. So
Oh,
using
okay.
the depth thresholding, we have
Mm-hmm.
calculated the masks.
So you don't do mapping in the beginning, but you do everything real time.
Yeah, real time using the depth images.
Okay, perfect.
So I have launched the world. Now I'm giving the pilot. Yeah. View, graphic. So, for the ROSBAC, what all files do we have to record, or what all topics?
The same topics as those you did for World 1 and World 2. Do you want me to name the topics one by one?
Uh, yeah, if possible, that would be great. Or else I can do.
So you need to record Mavrosh slash local position pose.
Okay. Slash Mavros slash local.
Can you just do Ross topic list and copy paste so that there is no spelling error, because then you might have to.
Yeah. I'll just screen it.
So it's Mavrosh slash local position pose.
Mavros slash local position slash pose.
Yes. Then you have to take Mavrosh state,
Mavros state.
Mavrosh slash state.
Uh, state. Yes. Yeah. Found it.
Clock, gazebo model states,
This is model states.
and Prius.
Yes.
Yeah, that's it.
Okay. So I've given the takeoff. Console is ready. R2T I have run. R2T. I think it will take off. Oh, I haven't given takeoff. I'll give takeoff again. I'll just give it manually. So I've given the takeoff now, and this is, we don't need this one. RQT is running and this is ready. I'll delete the log. Uh, Actually, I think there might be some FCU URL issue. We might have to change the FCU. Can we do that? And relaunch the world?
For the GPS or
Yeah, for
just
the
please go ahead.
GPS one. For
Go
the,
ahead.
yeah, for the communications.
Yeah.
Just a second. I'll just complete that and then relaunch it. So this was for the communication part. With this URL, it wasn't communicating. So we had actually changed just for the normal one. We forgot to change for the white. So I'll just relaunch the white and we'll run the code.
So we cannot hear you. Yeah.
Yeah, yeah. We are waiting for the GPS. Yeah, so the GPS has come. Now I'm taking
Um.
off.
Wait,
Just a
wait, we
second.
cannot.
Maybe
I
the,
cannot see your screen. I'm not sure if that's the case for everyone.
Yeah, we can't hear that.
okay. Just a second. Maybe there might be the internet had dropped. One allow. Yeah. Is the screen visible now?
Yes, you are back.
Yeah. So there was a maybe network issue. Yeah. Now I'm giving the takeoff. The GPS has come, and I have run the RQT. And I'll delete the launch pad.
Please remember to record the back file.
Okay, sure. So now I'm running our final code, and I've started the back file recording as well. Okay, I think maybe let's go down. Just a second. I think the script counts like this. Can we get one more run, uh, if possible? Like that would be helpful.
Okay for me. If everyone else is okay.
Why your car is moving now?
Actually, I have stopped the script.
Okay.
I think it was already set on the neutral gear. So as soon
Okay.
as I
Okay.
stop the script, the car starts to go. Uh,
Okay. Yeah,
we'll just run
you
it
can have
once.
another run. Yeah, yeah, once more, but just try to be a bit quicker.
Yes, I'll be quick. I've launched the world. Started the GPS navigation. This file is traffic. Started the RPT.
उधर भी कुछ तुम लोगों को बाल भी नहीं किया सो गिर रहा था मैं
Yeah, so the GPS has come. Now I'm giving the takeoff. RPT is already running.
I was sleeping.
I delete the launch pad.
कुछ नहीं दौड़ पा रहे कुछ नहीं है तो तेरी टेंशन ना लोग अपनी तेरे को बाहर जाके इतने दिन में 10 बार कॉल करते हैं और ये एक बार भी नहीं
Start
करते
recording the back file too.
Back file recording I've started and I've run the file.
Right. करवाया करो क्यों कर रहा है मेहंदी लगा लो
Waiting for the car to get detected. Once it detects the car, then we'll start following it. So here, as you can see, sometimes the images get blacked out. That is due to the mask parameters. So that is why it is getting blacked out in the middle. But it detects the car well. And once we have given the car the following command to follow the path, the drone follows the car. So using the car center and the car's orientation, we are giving the following commands to the drone to follow the car. So wherever the car goes, the drone follows the car. So in that way, the car follows the path and the drone keeps following the car. So that way, it completes the path. And like since the uh, this thresholding is a little bit sensitive to the slopes also, so each world will have a different set of mass parameters. With these set of parameters, the two worlds that were shared, they were working fine. but then since the slopes are different, so the mask parameters will also be different. So I think that is why it is facing these blackout issues, because it is not able to create the mask properly. So I think that is the issue that we are facing here.
Okay, I guess if you think your turn is like if your run is finished, you can stop it and also stop the bad files.
Just a second.
Hmm. And can you share so you have to upload the back file, right? Can you share your MD5 sum for the back file?
Yeah, actually, we would try another run if we are given a chance. We would like to try one more run.
Okay. Not sure. What do
No,
others?
actually, I think two are enough.
Uh, okay, sir. I'll just share the
Can
empty
you
sum.
can you display the MD5 sum for the back file and
Uh,
paste it?
what is the? Can you just
MD
tell me the command?
MD MD5 SUM
MD5 SUM
and then the file name.
and
Eh,
okay, I need to make the bigger one. Okay, yeah. MD5 sum 2022 03 26 11 58. Yeah. Shall I put it in the chat?
Yeah, can you copy paste in the chat the whole line? Yeah, whole
The
line.
whole line. Okay.
Yes. Could you put it in the chat?
Yeah, I have put it in the chat.
Okay.
Sir, if possible, can we get one more run? Just one more run,
Um,
if possible.
I don't see it. Can you?
I can run if you will allow. Like, we're thinking we could get another run. Shall I run once again, sir? By your permission. It will take just 5 minutes.
I would. So what? I think you've already taken a lot of time.
That would be unfair to other teams, I think. So,
Okay. Okay. Fine, sir.
yeah.
Can you just? I could not see the MD5 sum in the chat. Can you please verify you have put it?
Okay. Just a second. I put maybe net Discord. I put once again.
All right. Maybe it's your internet issue.
Yeah. Just a second. We are fixing that.
Team 11, you can lead.
We have shared it in the chat. Is it visible now?
Yes, I see it now.
Okay. Shall we leave then?
Yeah.
Okay. Thank you.
Teammate will be joining now. Teammate, presenters, please raise your hands. Shikhar Gupta, please accept the invite to stage request.
तू शेयर कर रहा है? No.
Is the screen visible?
Um,
Am I
teammate,
audible?
are all your presenters here?
Yes.
Okay, like only three of you are here.
So from this PC only we'll be presenting as well as speaking. So if that is fine. Yeah, am I audible?
Teammates, start presenting.
Is the screen visible now?
Yes, the screen is visible, but your audio is very low.
Okay. Is it better now?
Try saying something.
Hello.
Yeah, it's still a bit low, but you can continue.
Yeah, sure.
So, are you going to map or you are directly starting the navigation?
So in our script, we have the capability of storing a map as a array, but that is not being used by UGV application.
So, you are navigating and mapping at the same time.
Uh, No, so actually, through the UAV's feed we can map the whole terrain, but the UGV's navigation is not based on that particular map. It's independent of the map. It's happening in real time using the UAV's camera.
So, the reason I'm asking, so you are not going to use the world with the color overlay, the image overlay.
Sorry.
So you are not going to do a separate mapping run on a world with image overlay. You are directly running on the white environment.
So we can do both, sir. If it is required,
Now, it's
we
up to
start.
you. Whatever you think would work better. There is no hard and fast rule, but I'm just clarifying.
Yes, so since we are using the depth image for the road detection and navigation of the UV, and based on that depth image, we are navigating the UGV based on the UAV's camera feed. So since the depth image is same in both the worlds, so we can navigate
Okay,
the UGV.
perfect. So, yeah, so you can just start and make sure to record the back file.
Yes, sir. So should we start?
Yes, please. Can you, yeah, can you display some, yeah, feedback? Yes.
Yes, so this is the depth image of the drone. Once this navigation script starts, there'll also be a couple of images which we show.
Okay.
Yeah. So can we delete this slab because it may interfere?
Yes, you can.
So this is the car's blue blue line is the current trajectory of the drone which has been detected, and the red line is the required changes in the car's trajectory to align itself with the drone script. So once we run the drone script, so so the car has been fortunately stuck. So if it is possible, can we relaunch it?
Can you repeat?
I'm saying the car has been stuck. Like, so can we relaunch it again?
You may run it once again, but not more than that.
Sure. Yes. So in the meantime, I'll also explain you what we were doing. So what we are
And you
doing is,
can start another back file, please.
yes.
So when you start, your quad flies away.
Yes, so that is like by mistake. Another
Okay.
autopilot script was running, so we just
Okay. Okay.
get this closed. So what we are doing is we are based on the difference in depth of the road and its surroundings. So we are detecting the road patch, and we are making the UAV follow that particular road patch. So that will be same in both the roads. And then in since in the white world the car's features will be easily identifiable. So we are detecting the car's position and just making the car follow the UAV.
Okay. And you're detecting the road based on the depth information, right?
Yes, sir. Yes, sir, because the in the three worlds which were provided earlier, so the RGB features were not that good to distinguish the road from its surroundings, so we decided to go for with the depth imaging.
All right.
So like unlike the three words provided in this world, the depth data is not like that drastic as compared to the three words. So probably that's why the performance is not that satisfying. So gazebo unexpectedly just closed. So I don't know. It's willing to do what you do.
Did you reset the models or did you restart the simulation?
No, so just now, sir, like gazebo just closed. So we're not sure why.
So you restarted it, right? Relaunched
Yes, so
the.
now we are restarting. Yes.
Okay. Because I think if you reload the model, the Mavros might have issues. So you have to relaunch.
So this is the car being detected in the RGB meteor. Now I drones. For that I'll start the house.
You started your back file, right?
Yes, we are recording. Yes, so the car could run only till this point. It's probably because of the initial position of the car. So what in our words we had taken was it was a bit behind the drone's initial position, and also the like difference in this world and the features in the previous
Okay.
ones.
So now, can you just I guess the run is done, right? So you can just
Yes.
share the back file, one of the
Okay.
two, not both, one of the two, whichever you think is better. And can you share the display the MD5 sum for that file on the screen now?
So, sir, like in our earlier simulations, what we had done was uh,
Mm-hmm.
we had taken the car's position a little behind the UAV's position initially, so that the UGV can follow the UGV basically. So, in this uh, in this world, since that's not the case, so can we, if it is possible, change the UGV's initial position, then try
Can
again?
you speak a bit louder, please?
Yes, sir. So what I'm saying is, in our algorithm, what we have basically done is we are making the UGV follow the UAV. So the initial position of the UGV is a bit behind the UAV, so that it can it, it lags a bit behind the UAV. So in
Okay.
this world, since that is not the case, the car is spawned ahead of the UAV. So that can be one of the probable reasons for the car getting stuck. So if possible, can we uh, change the UGV's initial position? Is this?
I think at this point we cannot allow that because it will be unfair to other teams.
Sure, sir. Sure, sir.
Yeah. Can you just copy paste this MD5 sum into the chat?
Yes, sir.
The whole line. So there's a file name also. Yes. Thank you.
Yes, I should I stop sharing my screen?
Yes, you.
Okay, teammate, you can leave. Now team 5 will continue. So team 5, please raise your hands. Team 5, you can join. You can start and
Hello, am I audible?
Yes, we can hear
uh,
you.
Hello, good afternoon. So I'll begin with my demonstration. Is my screen visible?
Yeah.
Hi there, am I audible? So, like first, we'll do phase one, which is the mapping phase, which is performed on the world. Sorry about that. Which is performed on the world with the texture, and then we'll do phase two, which is the UGV navigation, which is performed on the world without the texture.
Okay.
So, like, I'll, I'll record the raw spark file as well. We'll wait for the GPS fix. So the drone has taken off. Here is the terminal of the path planning module, which displays the waypoints it will go to. And like initially we use the UGV to determine the direction in which we are moving. Like we do not assume any particular direction at the beginning, and we move towards the direction in which the UGV is pointing. So like as you can see, it has detected the UGV, and like the blue circle is the rear side and the red circle is the like front side, so it is moving towards that. Over here are the RGB and the depth images, and over here you can see the segmentation for the lane. For lane segmentation, we have used a very robust algorithm which incorporates both color, like RGB data, as well as the depth data. And so even so like as you can see, there are like these uh, kind of these areas which are not which are kind of fall positives, but that won't affect because we perform morphological transformations that will erode down the mask and will give us the exact not like it will point us towards the center of the path, and our UAV follows that path. as you might see, like there might be some false positives in UGV detection as well, but like this is taken care of because we perform eccentricity checks on the ellipse that is being fit.
So the map at the bottom right is the depth image, right? Or is it the
At the
final map?
bottom it is the like it is the segmented out lane that we like
Right.
process to find out the final waypoints that we'll give to our UGV.
Okay, and that's constructed using both RGB and depth.
In depth, right?
Okay.
As you can see, the iris is over here, like this small white pixel, and like it is almost like it is covered more than half the path, but there's still a long.
Why did it get slower? Is it because your real-time factor is horribly low?
I'm not sure. It might be because of my system. Like the real time factor got really low. Like
Yeah, it's really, really low. But it's okay. Let it take its time. This essentially means that the simulation is running 100, roughly 100 times slower than, or 10, yeah,
okay.
roughly 100, 10 times slower than real.
Yeah.
is it also checking if it has been already at some point?
Yeah, so like our path planning algorithm basically like what it does is, so as the path is being detected, uh, it uh, it goes to those waypoints, and suppose there is a like false positive somewhere, or like it deviates from its path and it gets stuck in a dead end. So what we basically do is we create a buffer zone around the already previously added nodes in the path. And so if like and we try to go in a direction which is like the direction in which we go is almost like it is a continuation of our previous trajectory and does not deviate too much. For that, we do a dot product with respect to our previous trajectory. So basically, if it tries to enter into a previously visited buffer, or if the dot product threshold is too low, we backtrack. Like we come back a node or two behind in the graph, and then try to resume the exploration process. And in this way, like we can ensure that it doesn't deviate too much from the path, even if there are false positives.
Great. Yeah, because I saw it turn 180-degree 2 times, so that's why I.
Uh, yeah, so like it is turning because we also like try to maintain the yaw in such a way that the lane being detected is vertical. Because since our like image orientation is landscape, if the road is horizontal, there might be cases where like the entire frame is like occupied by the road, and there will be then trouble in extracting the boundaries of the road. So to like we try to maintain the yaw in such a way that the road is nearly vertical.
All right. Thanks. Okay, would it help speed up the real time factor if you closed the RVs?
I can try that.
No. Okay.
Not really.
So, what could be the reason behind this?
I think it's probably because the computer they are using is low on resources, so
Okay.
therefore it takes longer to simulate one step. Like,
So probably you can close all the unnecessary windows.
Yeah, like I do not have any, and all of these are required for the simulation.
Right,
So
right.
just to double check, can you type htop on a terminal?
etch top on a terminal.
htop or top, whatever you have installed. Right. So all the processes are used.
So while this runs, can we call the other team? Let it run in the background.
Oh, like the one presentation can happen at like at once only one person can present. So is that not a problem?
Yeah, I guess team 5 can stop sharing and we but keep
Mm-hmm.
running the simulation, right? And that will also speed up probably the
Yeah.
Yeah, sure.
Okay. Okay, I'll let
and
the
just
other team
just to
know
make sure
too.
keep running your ROSBAG file.
Yeah, yeah, definitely.
I'll let the other team know. It might take 5 minutes or so. Team 13 would be joining.
just now.
Uh, Team 13, your other presenters, when are they joining?
Hello, sir. I think, can you actually wait for a few seconds? There will be another one joining.
Team 13, could you start presenting?
Sorry, sir. So we have not shown the overlay thing. So I think if we, it is enough if we show the if we just show the overlay thing right now.
I guess now you have to do the mapping again, right?
Yes, sir. So like, do you want me to launch the normal world again or no?
You would need to use a map, isn't it? Or are you doing simultaneous? What is your approach? Do you have a one run for map and one run for navigation, or is it combined?
Uh, it is like one run. Like the drone will be mapping the whole world, and then it will.
And then you run, yeah. So you can do that, like do a whole fresh run.
Okay.
And please don't forget to record back files. You only get one shot.
Yes.
Sorry, please make sure you are recording all the topics that are required.
Yes. Can you just confirm that these are the required topics?
Um, you need
Slash
press,
press.
just press, yes. Clock, local pole, state, yes. Okay, there is one extra topic which is not required. Oh, that's the name. Okay, that's perfect. Yes.
Yeah. Yes, sir. Here for takeoff, we are actually using drone kit, and then for running the Python file, which has all this script, we'll be using we'll be actually publishing into the topic of the Mavros.
Okay. Can you share your map also, where like a screen where the map is being built?
Yes, yes.
So how does the quad decide to go in that? Uh,
Yes, sir. So, like, I think this is the depth image, and in which this is the road, this almost white overlay, and it
all
is
right. So
falling
this
this line.
is so it's right now making a map, right? By using the depth image,
Yes, sir.
right?
Exactly.
Okay.
Yes, sir. That is a segmented image of the road as well as what they like.
So, do you want a brief on the procedure? Like, what exactly are we doing?
If you wish, you can explain.
Okay, sir. So, first of all, we have received depth images from the depth cam that is mounted on a drone. So, what we do is since the representation of the depth image is somewhat like grayscale type. So, what we do is we finally create a pseudo grayscale image from the depth image obtained from the depth cam. I'm sorry. And what we are doing then is we are applying k-mean segmentation, and we are segmenting the obtained pseudo grayscale image into two classes, which are the two classes being road and not road. And finally, what happens is we work under the assumption that the major class, let's say now that you see that major class in this segmented image is white and the minor class is gray. So we work under the assumption that the major class that we have in the pseudo grayscale image would be of road. Since the drone uh, started from the area where road was the majority and has to traverse along the road, so this assumption works fine. And then what we have done is relative to the drone, that is the image frame, we have decided that the drone will only move in the y. If you take the image frame, it is the drone is moving along the y-axis, while the x-axis is like segmented into two parts that are white and gray region. So we work under this assumption that the drone will move along the y-axis. And finally, what we have done is we have taken the midpoints of the roads, the road points along the y-axis. And finally, we have found the centroid of that same region, and the drone moves along the same.
That is what we are doing. It is following the red line created.
Yes, sir. So since the UGV has traversed and it has got stopped where it was stopped in the world with the texture, so it was independent of the texture, and now I am moving the UGV with the help of the information generated by the UAV.
All right. So you can record a separate back file for the navigation.
Yes.
And for moving the UGV, what we have done was we have recorded the CMD velocity topic of the macros, and then we are actually in a bag file, and we are giving the same bag file to the UGV. So there should be a conversion of twist messages into control messages, as drone has twist messages as and UGV has control messages. So we'll be doing that. We have done it in a Python script. So that is how we are actually navigate using the ROS bag file to actually to give it to UGV.
So now you are essentially not using a drone, but the Prius will move on its own. Is that
Yes,
correct?
sir. Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir. We're not
Yes,
using a drone.
actually, that was what the problem statement was. We weren't really allowed to move the drone and car simultaneously. So that is how we had to approach the problem.
Okay, I'm not sure about that, but okay. A quick question: how does your car get feedback about where it is, or
The
is it
only
an
thing
open
is
loop?
that yes, in that case, we should actually maintain constant velocity, like the velocity at a point. If drone has certain velocity, the car should also have the same velocity in the forward direction, so that it doesn't actually get misplaced. So this is the only assumption and the only thing which we have to fit in the drone in the UGV, so that it actually follows the same path as UGV. So when there is no proper conversion between twist messages into control messages, there might be this you will not have this feedback loop and TID control.
All right. So indeed, it's like an open loop controller.
Yes.
Okay, perfect. So is the run finished?
Yes, sir.
Yes.
Okay, great. So you can upload the back files, and can you display the MD5 sum for these back files for both the back files?
Yes, sir. So this is for the phase one, and
Yeah, can you put it in the chat, the whole
yeah,
thing with
yeah.
the back file name?
Like I think I will rename this file.
Yes, that.
This is for the phase one and phase two.
Yes, and also the other file, please.
So this is for the phase one.
Thank you.
team 5, you can present again.
Just one sec. So because of the very low real-time factor, it hasn't been able to explore the entire area. We are not able to figure this out, like why exactly this has happened. So like if you guys want, I can run the UGV navigation till the point like the UAV has explored.
I think we can go ahead with that.
So I'll shut this down and I'll start UGV navigation. I'll switch off the ROS bag recording. Start another recording for the ROS bag. We'll again wait for the GPS fix.
Just to be sure, you're recording the back file, right?
Yeah, right.
Great.
So here basically what we are doing is like we try to keep the UGV inside the frame of field of view of the UAV so that we are able to localize the UGV with the help of the UAV, since the UGV does not have any sensors of its own. We detect the UGV and we find the center coordinates of the UGV by using image moments, and we also like find the major axis of the ellipse, which points which gives us the yaw of the UGV with respect to the UAV. And as you can see, if the UGV like, tries to get out of the frame of view, like 90% boundary of the like, field of view, it like the controller slows it down so that the UAV is able to catch up with the UGV. And because if it is to get out of the field of view, then we won't be able to localize it.
Your UAV is not collecting any data right now, right?
Sorry, could you UAV or UGV?
UAV.
So, no, my UAV isn't collecting any data right now. It is solely used for the purpose of localizing the UGV.
Okay. It's moving pretty nicely. Good to see.
Yeah.
Can we run the same simulation again with the image?
The same simulation but with the image.
Yeah.
Oh, okay. I'll try to do that.
No, just let it run.
But
Let this run finish and then you can.
yeah, sure.
Oh, your real-time factor drop again suddenly.
Yeah, like as you could see, it was moving pretty nicely, but I think there is some issue in the mesh because it is like dropping at the exact same point it dropped for the phase one.
Hmm. So I have a question. How do you take, because I suppose you would also have to write low-level controllers for the UGV because its dynamics is different, right?
Right.
So how do you take into account that? Do you just take the waypoints as waypoints for UGV and then use the natural dynamics, or do you change the waypoints to make it more feasible for the UGV?
So we use an MPC controller for controlling the UGV, which basically like takes into account the waypoints it will receive in the future, and like it looks into an horizon and tries to smoothen out the points in that horizon. So it is like able to perform very well on sharp curves as well.
Okay. Should we stop it here?
I think that like this will move nowhere. Like at this
Because
real time
real-time factor is
factor
really
is
low.
very low. Yeah, so it's no point.
Perfect. So if others are okay, Sudesh or Akshay sir and Hit, then should we stop this here?
Yeah.
Yeah, that's fine
Yeah, we
because
can stop.
logic seems to be quite good and it has covered a lot of path. We can stop it here.
Yeah. And then if you want now, you can run it on the colored
Yeah,
map.
right.
Just one sec.
Make sure to save the back files for this run.
So actually, we are not really sure how it will perform on like the terrain with the RGB like texture. Uh, because we
Right.
like
So,
algorithm utilizes the fact that we are to traverse in a like snow covered terrain.
So you're not sure whether the car will be detected properly. Is
Yeah,
that your
like the detection of the car, which you can see, like it is. We haven't really tested that out on the world with the texture.
I think you must
don't
give
worry.
it a try.
Let's try. Yeah.
Yeah, yeah. We won't
Okay,
mark you on this just
we
to
can
check
try.
how it looks on the road. Yeah.
Yeah, and in future you can put a QR code on your card, this card, some
Yeah,
code.
that will help in the
Hmm.
localization for sure.
Exactly. Yeah.
I'll have to change a few launch files. I'll just do that.
Don't worry.
Uh, so actually, we'll have to run the exploration as well on the world, or like do we have to run it again, or can we use the same path as the previous time?
I think you can use the previous map uh, just to save time, and this is just for to see how it looks. So if you think it will be very difficult to detect the car, try it once. If it fails, you can, since this
Yes.
is not for evaluation, you can make use of the ground truth of the car position, just the feedback of the car location.
Yes, we are trying the like trying the detection with the text as well. Let's see how it performs. Uh, I do not know. So I think I can probably run it if I restart it once again. Should I try it?
Yes.
Yeah, try once. Try once. Yeah.
Ah. Mm, I think.
The quad is not yet did not take off yet. So
Yeah.
and this is the wrong long file, I guess, because it's white.
Yeah, yes. I think I by mistake I loaded the wrong world.
It's okay. You can make the this particular file run on your own, and you can show it
Okay.
tomorrow.
Oh,
Maybe during
okay.
the presentation, just show a short video of it.
Okay, so
Yeah.
And I think it should be okay. Do you think it should be okay if they use ground truth? Because I don't know how the car detection will go with the texture.
No, he can put a Aruko marker or something like that over the top of the car.
Yeah, right. And I guess the quickest way would be just to use the ground truth from Gazebo.
Okay. So
So
whatever you are comfortable with.
I have one question. So as we have seen in your simulations, that your simulation starts pretty well, but after some time it becomes very computational intensive. Why is it so?
So we probably think like we ran two simulations, one with the texture and one without a texture, and at the same point, the real time factor dropped. So like it might be because of certain interactions with the mesh given to us in the simulated world. That might be the reason. It like in the previous two worlds there we didn't encounter this, and like there was no sudden drop in the real time factor, and like it used to run pretty smoothly. But I think it's this because of like maybe because of the construction of the mesh or something that we are facing that issue.
Okay, so you are keeping the complete mesh data while in the simulation, or you are localizing it?
No, so like Gazebo loads the entire mesh at once, so like the entire mesh data is present at once. So It
I
Okay.
think this
it
is
might
this.
be because of certain interactions. Like we have seen that, if we for example, if we try to initialize the drone on top of the car, the real time factor drops because of the drone and car interaction, and it might be because of a certain kind of interaction between the mesh and the car.
Uh, Maybe you can analyze this, and tomorrow we can discuss it further during your presentations.
Oh, sure, sir, sure, sir. That can.
Yeah, it could also simply be because the actual world has is more denser at certain region, and Gazebo is requires more resources to simulate, which his laptop probably cannot provide, because the best real-time factor you get is already zero point 0.5, so that's already bad.
Yeah, like it might be that.
Yeah. Okay, so can you show the MD5 sum of your back files
Yeah,
of
yes.
the mapping and the run on the white terrain?
uh, MD5.
You just type MD5 SUM, no, without space,
Uh,
and then file name. Yeah, and for also for the other one. Perfect. Can you copy paste these two lines along with the file? Yeah, in the chat. Perfect. Thank you.
thank you.
Uh, okay, panelists, this was the last team. So thank you each of the panelists for joining this session. we will end the session here. Thank you, everyone.
Thank you so much, Muskan, and my special thanks to Heth and Gaurav. Thank you so much that you have taken so much interest in this particular problem, and you have guided the whole team regarding this.
Yeah,
Uh,
thank you, team.
yeah, it's our pleasure. Thank you also for.
Gaurav, what do you do actually?
I'm a PhD student in Max Planck Institute
Okay,
for
okay.
intelligent
Uh,
systems. Yeah, I work with micro robots.
okay, very nice. And you
But
did your bachelor's from IIT Kharagpur, right?
yes, yes, yes. And when I was there, I was working on drones in the